Have you ever wondered about the connection between the ancient art of origami and modern engineering? Well, let me tell you, there's more than meets the eye. What if I told you that this intricate art of paper folding, born hundreds of years ago in Japan, is now revolutionizing the field of engineering? Yes, you heard it right. Origami, an art form steeped in tradition and simplicity, is providing inspiration for cutting-edge innovations in engineering. Origami, at its core, is about transforming a flat sheet of paper into a three-dimensional form through the process of folding, but it's not just about making pretty shapes and models. It's a discipline that marries art and science, blending aesthetics with precision and creativity with mathematical rules. Every fold, every crease, every twist in an origami model follows a certain geometric pattern, and it's this mathematical underpinning, this language of angles and ratios that's caught the attention of engineers. They're finding that the principles of origami can help solve complex problems, from designing foldable structures that can be deployed in space to creating tiny medical devices that can navigate the human body. But it's not just the math that makes origami so appealing to engineers. It's also about the philosophy behind it. Origami teaches us to be resourceful, to make the most of what we have. A single sheet of paper with no cuts or tears transformed into a beautiful, complex figure. It's a lesson in efficiency, in simplicity, and in the power of transformation. So how does this ancient art form connect with the high-tech world of engineering? It's all about the principles of transformation, of making complex shapes out of simple ones, of finding beauty and functionality in simplicity. These are the principles that engineers are borrowing from origami, applying them in ways that could change our world. So, you might be wondering, how does this relate to engineering? Stick around to find out. Think about space, a realm of infinite possibilities and extreme conditions. How do you think origami fits into this picture? Well, it's quite fascinating, really. Picture the vast expanse of the cosmos, an environment that's incredibly harsh and unforgiving. Now, imagine the challenge of sending large structures like solar panels and telescopes into that environment. These structures need to be expansive when operational, yet compact for the journey into space. This is where the principles of origami come into play. The idea behind origami is quite simple: transforming a flat material into a complex, three-dimensional shape. This principle is being ingeniously applied to design large space structures. When these structures are launched, they are folded compactly, much like a piece of origami art. But once they reach space, they unfurl to their full size. Take, for instance, solar panels. These panels are essential for powering spacecraft, but they are also large and unwieldy. To solve this issue, engineers use the principles of origami to design solar panels that can be folded into a compact shape for launch. Once in space, these panels unfold to their full size, ready to capture the sun's energy. Similarly, space telescopes also benefit from origami-inspired designs. For a telescope to function effectively, it needs a large mirror to collect as much light as possible. But launching such a large mirror into space poses quite a challenge. By applying origami principles, engineers can design mirrors that fold compactly for launch and then unfold to their full size in space. These are just a few examples of how the principles of origami are helping us explore the cosmos in ways we never thought possible. From solar panels to telescopes, origami is revolutionizing the way we design and deploy structures in space. Incredible, isn't it? But the uses of origami in engineering are not just confined to the cosmos. Now, let's dive into the microscopic world of medical devices. Origami, in its essence, is about transforming a flat sheet of paper into a complex three-dimensional shape through folding. This principle is now being applied to the field of medicine, specifically in the design of life-saving devices like stents. Imagine a tiny device that needs to be inserted into a blood vessel to keep it open. This device, called a stent, has to be small enough to navigate through the narrow pathways of our body, yet expandable to provide support once it reaches its destination. That's where the principles of origami come into play. Engineers have drawn inspiration from the ancient art to design stents that can be folded into a compact size for insertion, then unfolded once inside the body. The stent begins as a flat structure, just like a piece of origami paper. When it's time for the stent to be inserted, it's folded down into a smaller cylindrical form. This makes it easier for doctors to guide it through the body's blood vessels using a catheter. Once the stent reaches the right spot, it's time for the origami magic. The stent unfolds, expanding to fit the width of the blood vessel. This not only keeps the vessel open, but also provides a supportive structure that can help prevent it from collapsing or closing up again. Stents are not the only medical devices utilizing origami principles. From tiny robots designed for targeted drug delivery to collapsible heart valves, the potential applications are vast and fascinating, and it's not just about size and shape. Origami-inspired designs can also provide better flexibility, allowing these medical devices to move and adapt to the body's natural motions. It's a perfect marriage between art and science, tradition and innovation, all working together to improve the quality of our lives. So you see, from the vastness of space to the intricate world of medicine, origami principles are everywhere. But it's not just high-tech applications, origami is also transforming everyday objects. Take maps, for instance. We've all grappled with a large, unwieldy map at some point, trying to fold it back into its neat, compact form. This is actually a practical application of origami. The pleat fold pattern, used in maps, allows them to be opened up for a full view of the terrain and then folded back into a pocket-sized format with ease. Now, let's consider packaging. Ever wondered how your online orders arrive in a neatly packed box, regardless of the product's shape or size? That's origami at work. The principles of origami allow for efficient use of space and material, reducing waste and making transport and storage easier. Packaging designs inspired by origami can be folded flat when not in use and then expanded to securely hold items of various shapes and sizes. Moving on to furniture, origami has marked its presence there too. Designers are increasingly turning to the art of paper folding to create innovative and flexible furniture solutions. Foldable chairs, tables, or shelves, anyone? These are not just aesthetically pleasing, but also practical. Origami-inspired furniture can be folded into compact shapes for easy storage or transportation and then expanded when needed. It's a perfect solution for small spaces or for those who are always on the move. These everyday examples show us how the principles of origami are being used to solve practical problems, making our lives a bit easier and a lot more interesting. From maps to packaging to furniture, origami is helping us rethink the way we use space and materials, promoting efficiency and sustainability. So the next time you fold a map, unpack a box, or unfold a chair, take a moment to appreciate the origami principles at play. A centuries-old art form is not just surviving but thriving in the modern world, folding its way into the fabric of our everyday lives. Isn't it fascinating how an ancient art form has found its way into our daily lives? So we've seen how origami principles are applied in engineering. But how has origami influenced the field as a whole? The art of paper folding has done more than just inspire applications in engineering. It has fundamentally changed how engineers approach design and problem solving. By transcending the confines of traditional engineering, origami has introduced a new way of thinking that is flexible, innovative, and efficient. The very essence of origami is transformation. And this transformative quality is what has been so deeply ingrained into the engineering mindset. It's about taking a flat, two-dimensional surface and turning it into a complex, three-dimensional shape. It's about achieving maximum impact with minimal resources. It's about creating something beautiful and functional out of something simple and basic. This is the kind of thinking that origami has brought to the table, and it's the kind of thinking that is pushing the boundaries of what's possible in engineering. Origami has also taught engineers the value of simplicity. Instead of complicating things with intricate designs and heavy machinery, origami encourages a more streamlined approach. It's about finding the simplest solution to a problem, and then refining that solution until it's as close to perfect as possible. This kind of simplicity and elegance is something that engineers strive for in their work, and it's something that origami has helped to cultivate. Looking ahead, the potential for origami-inspired engineering is vast. As we continue to explore the depths of space, the intricacies of the human body, and the potential of renewable energy sources, the principles of origami will undoubtedly continue to guide us. After all, if a simple piece of paper can transform into a beautiful work of art, just imagine what a little bit of engineering ingenuity can do. In conclusion, from space exploration to medical devices to everyday items, the art of origami has indeed folded its way into the heart of engineering.